Imagine sitting back with your morning coffee while, two separate AI programs just ruthlessly negotiate a commercial lease agreement.
Right in the background.
Exactly, just running on your desktop. And they're doing this completely unprompted by you. Like one is aggressively redlining a penalty clause,
Yep.
and the other is, well, it's countering with data pulled from regional property laws.
Yeah, hammering out a compromise in literally seconds.
Which sounds like something straight out of a sci-fi novel. But as of today, July 15, 2026, the economics of artificial intelligence just made that kind of scenario a very real possibility for you.
It really does fundamentally alter what we consider daily work. And I mean, it's entirely due to the architectural shifts we've seen in just the last week.
Yeah.
Because the gap between a flashy AI demo and actual practical utility, it's always been massive. We usually get swept up in the hype, but the real world application kind of falls flat.
It totally does.
But what happened 7 days ago really changed that trajectory.
Okay, let's unpack this. Because exactly 1 week ago, xAI dropped a massive disruptor into the tech world, which is Grok 4.5.
A huge disruptor, yeah.
And our mission for today's deep dive is to cut straight through that typical tech hype. We are going to look at the hard data to see if this model is actually going to change how you code, how you work, and how you manage your daily workflow.
Right. We want to know if this thing is actually the real deal for the listener.
Exactly. And to do that objectively, we've got a really deeply vetted stack of sources today.
We do. We're analyzing official xAI release data, plus performance analytics from artificial analysis.
Yep.
And we also have highly specialized task benchmarks from Snorkel AI, along with a variety of independent stress tests that have just been running nonstop since the launch.
Right. Now, before we get into all the math and the benchmarks from those sources, we kind of have to acknowledge the personality of this thing.
Oh, definitely. You can't ignore it.
The data points out that Grok 4.5 retains that original spirit, the one inspired by the Hitchhiker's Guide to the Galaxy.
Yeah.
So interacting with it often feels like you're talking to a highly sarcastic friend who might, occasionally roast your prompt structure.
Yeah, it will absolutely let you know if your prompt is bad.
But that same sarcastic friend also happens to possess the analytical brain of a top-tier SpaceX engineer. It's just a bizarre, highly capable duality.
It certainly makes for a unique user experience, that's for sure. But we really have to look past the sarcasm today.
Right.
Our goal isn't just to list off what Grok 4.5 is capable of doing. We need to explore why its specific architectural choices actually matter to your daily workflow.
Makes sense.
Because the engineering happening behind the scenes dictates exactly how this tool behaves when you're, say, trying to meet a critical Friday deadline.
Right. So before we put it on the track and look at the lap times, let's look at the engine xAI just built in their Memphis data centers. Because massive feels like a completely inadequate word for what they've constructed here.
It really is an understatement.
The sources note the model boasts approximately 1.5 trillion parameters, which is a threefold increase from its predecessor.
Yeah, 3 times the size.
And when I was trying to visualize 1.5 trillion parameters, my immediate thought was just a massive library. Like taking your local town library and instantly upgrading it to the entire Library of Congress.
I mean, I see where you're going with the sheer volume aspect, but a library analogy can actually be a bit misleading here.
Oh, really? How so?
Well, parameters aren't really books on a shelf or stored facts. A much more accurate way to visualize it is to think of a colossal, unbelievably complex plumbing system.
Plumbing. So we're talking about pipes and valves instead of books.
Precisely. In an AI model, the data you input your prompt is like water flowing through this massive network of pipes.
Okay, I'm with you.
The parameters are essentially 1.5 trillion microscopic valves at every single intersection. During the training process, the AI learned exactly how much to tighten or loosen each specific valve.
Wow.
So that when your prompt flows through, it is routed down the exact right path to produce the correct answer at the very end of the system.
That makes so much more sense. It's not looking up a stored answer in a book. It's physically routing the logic through 1.5 trillion decision points.
Exactly. And what's fascinating here is how they actually calibrated those valves. Grok 4.5 wasn't just fed random internet chatter to make it a fun conversationalist.
Right, it's not just trained on Reddit posts.
Exactly. The training data was incredibly dense. They used high-level science, advanced engineering, complex mathematics, and crucially, real developer activity.
Through that collaboration with Cursor, right?
Yes, a deep collaboration with Cursor. So it is custom plumbed for highly complex problem solving.
So it's structurally built like an engineer. But how does it process that scale of information efficiently? Because the sources mentioned, it relies on something called mixture of experts and reinforcement learning.
Right.
And all of that is built on the foundational transformer architecture from that famous 2017 paper, Attention is all you need.
Yes, the classic.
But I mean, 2017 feels ancient in AI years, so how is that still relevant today?
Well, that 2017 paper is quite literally the bedrock of everything we are discussing today in this deep dive. Before transformers, AI models process text sequentially, like almost word by word.
Okay.
The problem was, by the time they reached the end of a really long paragraph, they essentially forgot what the first sentence was even about.
Oh, so they had terrible short-term memory.
Exactly. The transformer architecture changed that entirely by allowing models to look at the entire context of a sequence simultaneously. It pays attention to how every single word relates to every other word in your prompt, regardless of how far apart they are.
Got it. Hence the title, Attention is all you need.
Exactly.
So Grok 4.5 is still using that foundational concept, but they've drastically evolved it using this mixture of experts architecture you mentioned earlier.
Yes, and the mixture of experts, or MoE, is really the key to its efficiency. Wait, let me ask you, when you think about a 1.5 trillion parameter model answering a question, do you assume it uses that entire network for every single prompt?
Honestly, yeah, I did. I assumed if I ask it to, like, write a simple email, it's firing up the entire 1.5 trillion valve plumbing system to do it.
Most people do.
Are you saying it literally walls off parts of its programming depending on what I ask?
It absolutely does, and that is the pure genius of MoE. The system is divided into specialized subnetworks, or experts.
Okay.
So if you ask a highly complex question about quantum physics, a router at the very beginning of the system instantly analyzes your prompt. And it realizes, hey, I don't need the poetry experts or the culinary experts for this.
Oh, wow.
So it opens the gate only to the specific subnetworks trained heavily in physics and advanced math.
So it's completely compartmentalizing the workload. It's not lighting up 1.5 trillion parameters, which I imagine would cost a fortune in computing power.
A massive fortune, yes.
It just activates the specific clusters needed for that exact task.
Exactly. That targeted activation makes it incredibly fast and remarkably resource efficient. And when you combine that routing efficiency with its 500,000 token context window, the capabilities really just begin to multiply.
Okay, let's define tokens for a second, because we hear that word thrown around constantly in these deep dives.
True.
I think a lot of people assume one token equals one word, but that's not quite right, is it?
No, not quite. A token is more like a computational chunk of text. A short, simple word might be one token, but a longer, complex word like unbelievable might actually be broken down into 3 or 4 separate tokens by the AI.
Okay, that makes sense.
You can generally think of 100 tokens as roughly 75 words. So a 500,000 token context window means the AI can hold and process hundreds of pages of dense text.
Like a massive legal contract.
Exactly, or an extensive software code base. It holds it all in its active short-term memory all at once.
Being able to just drop hundreds of pages of code into a chat and just say, read this, is a massive workflow upgrade. But the xAI data also highlights something called cache discounts that are tied to that context window. What is that?
Well, this is where the engineering directly impacts your wallet. Let's say you are a developer and you're working on that same massive code base every single day.
Okay.
Historically, every time you asked a new question in a new session, you paid the computational cost to have the AI reread and process that entire document from scratch.
Ugh, that sounds expensive.
It was. But with cache discounts, the system remembers or caches that context. You don't pay the full computational cost to upload it fresh every time.
Ah, so it keeps the document warm in its memory, so to speak.
Exactly.
Add in the strong tool calling, the vision modalities, meaning it can actually analyze complex diagrams or images you upload, and this configurable reasoning setting.
Yes, the reasoning settings are key.
The sources show you can manually dial the reasoning engine from low to medium to high, basically depending on the difficulty of your problem.
Which perfectly complements the mixture of experts efficiency we just talked about. You can manually tell the system, hey, I just need a quick summary, keep the reasoning low to save time and compute.
Right.
Or you can say, I have a deeply entrenched bug in my Python script, turn the reasoning to high, and really take your time on this.
So we have this massive, highly specialized plumbing system that can route tokens efficiently and keep huge documents warm in its memory.
That's a good summary.
But how does it actually handle the pressure testing? I really want to look at how it stacks up against the heavyweights we already use, like Claude Fable 5 or GPT 5.5.
Well, the independent benchmarks have been incredibly revealing, particularly in the realm of software engineering.
Oh, really?
Yeah. When we look at rigorous tests like Deep SWE, SWE Atlas, Terminal Bench, and Frontier SWE, Grok 4.5 is consistently ranking as the absolute leader, or at the very least in the top 2 or 3.
Wait, let me make sure I understand these specific tests, because these aren't just like, write me a Python script to calculate a tip kind of prompts.
Right, not at all.
What is a test like Deep SWE actually measuring?
These are severe stress tests. They evaluate an AI's ability to navigate real-world, highly complex software repositories.
Oh.
The test might drop the AI into a massive GitHub repository with thousands of files and simply say, there is a bug causing the login page to crash under heavy load. Fix it.
Wow. Just completely unguided.
Exactly. The AI has to autonomously search the files, understand the architecture, locate the specific error, write the corrected code, and successfully issue a pull request. It is measuring true engineering capability.
Okay, but here's where it gets really interesting, because I'm looking at the data from artificial analysis right now, and they explicitly note that Grok 4.5 isn't always the absolute #1 in raw scoring across every single one of these tests.
That's true.
Like sometimes it ties for first, sometimes it takes second place behind GPT 5.5. So for the listener who just wants to use the absolute best tool on the market, why should they care if this model is taking the silver medal on a few leaderboards?
Well, if we connect this to the bigger picture, raw benchmark scores are no longer the most important metric in 2026.
Okay, then what is?
The true breakthrough we are seeing with Grok 4.5 isn't just about eking out a 1% higher score on a coding test. The breakthrough is economic efficiency.
You mean the cost to run it?
Cost, speed, and resource management combined. Grok 4.5 features a highly aggressive pricing model. It's $2 per $1 million input tokens and $6 per $1 million output tokens.
Which sounds great on paper, but tokens are pretty abstract. How does that translate to the actual compute cost compared to the competitors taking those gold medals?
Well, because of that mixture of experts architecture we discussed, where it only activates the necessary pathways, Grok 4.5 takes a much more direct computational path to the answer.
It doesn't meander around.
Exactly. As a result, it actually uses up to 4 times fewer tokens to complete comparable tasks than its competitors do.
Oh, wow. So it's not just that the tokens themselves are cheaper to buy, it's that the AI actually needs significantly fewer of them to get the job done in the first place.
Exactly. And the artificial analysis data provided a stark, real-world example of this.
Why was the example?
For a complex, multi-step knowledge task, running it through a top-tier competitor's model might cost you around $11 in compute power.
Right.
Running that exact same task through Grok 4.5 brings the cost down to just $2.49.
$2.49 versus almost $12 for the exact same result. That just changes the math completely for a business.
It is a total paradigm shift. Achieving Opus-class frontier-tier performance at a fraction of the cost democratizes this technology.
Yeah, big time.
You no longer need a massive enterprise IT budget to leverage elite computing power.
Yeah.
It is now highly accessible to everyday users, independent developers, and smaller businesses.
Which leads us perfectly into what I honestly think is the most important part of this deep dive. Because if I'm only spending $2.49 for a complex task, my immediate thought is to just set this thing up to run on a loop all day long.
And you wouldn't be the only one thinking that.
Right. And the sources highlight that this cost efficiency is exactly what unlocks agentic workflows. Yeah. Let's define the actual mechanism here for a second. What is an agentic workflow doing technically?
An agentic workflow is essentially a loop of autonomous API calls where the AI acts as an independent agent.
Okay.
Traditionally, you type a prompt, you wait for the answer, you evaluate it, and then you type a follow-up prompt. You are babysitting the process.
Right, very manual.
But in an agentic workflow, you give the AI a high-level goal, and it breaks that goal down into subtasks. It executes step 1, evaluates its own output against the main goal, realizes if it made a mistake, uses a tool like a web search or a Python interpreter to fix it, and then moves on to step 2.
Entirely without your intervention.
Exactly.
Yeah.
Entirely on its own.
I want to make the mechanics of this super clear for the listener because the sources provide an incredible example regarding content creation. Let's say you need to build a complete marketing campaign about AI and space exploration. Historically, you'd ask the AI to write a blog post. Then, in a totally separate prompt, you'd ask for an outline for a slide deck. The AI treats these as isolated events.
Right, it completely lacks connective tissue.
Exactly. But with Grok 4.5 in an agentic workflow, you just give it the high-level directive, like build a one-month campaign on AI in space, including weekly blogs, social snippets, and a slide deck.
Yeah.
And the AI takes that directive and initiates the loop. It writes the first blog post, and then crucially, it stores the core themes of that post in its cache memory.
Yes, that cache is so important.
Right. So when it autonomously moves to step 2 to generate the slide deck, it pulls from that cache to ensure the tone and the metrics perfectly match the blog it just wrote. It literally passes the state of the project from one modality to the next.
And then it just continues. It might hit a roadblock where it realizes it needs up-to-date information on a recent satellite launch, so it autonomously calls a web search tool, retrieves the data, injects it into the slide deck, and finishes the task. It is quietly churning out a massive amount of interconnected work in the background.
And because of that $2.49 cost structure we talked about, you can actually afford to let it run that extensive multi-step loop without blowing through your API budget in a single afternoon.
Exactly. And the benchmarks back up its capability here, too. We looked at Snorkel AI's GDP-Val Plus benchmark, which specifically measures multi-step planning without human intervention.
And how did it do?
Grok 4.5 scored exceptionally high pass rates across specialized domains like legal analysis, healthcare administration, and complex quality assurance tasks.
We're seeing this deeply integrated into developer workflows as well, right? With tools like Cursor and Grok Build.
We are.
It essentially just sits inside the development environment, running in the background, anticipating issues, and writing blocks of code autonomously, while the human engineer gets to focus on the big picture architecture.
And for knowledge workers like financial analysts or project managers, it is autonomously handling complex Excel modeling, generating detailed architectural diagrams, and even parsing dense legal documents to extract actionable insights, all in a continuous loop.
So if I can get all this autonomous multi-step work for a couple of bucks, I should probably just automate my entire job, unplug my keyboard, and move to the beach.
Ah, well.
But looking closely at the snorkel data, I'm guessing that's a terrible idea, isn't it?
It is a very bad idea, yes. This is where we have to approach the reality of the technology objectively.
Right.
Because despite the incredible efficiency, there are distinct technical limitations. First, in certain specialized technical environments, users have documented a reduced context window compared to previous versions.
Meaning, like, if you aren't managing that cache effectively, it might just drop a crucial piece of information you fed it 100 pages ago.
Yes, exactly. But more importantly, while we just praised its agentic capabilities, ultra-complex expert tasks still have a very high failure rate.
Really? How high?
Well, if you look at the absolute most difficult top-tier expert tasks within that Snorkel GDP-Val Plus benchmark, Grok 4.5's pass rate actually drops to around 29%.
29%. Wow. That means it is failing, what, 7 out of 10 times when confronted with the absolute hardest, most nuanced professional problems.
Yes.
Why does it struggle so much at that specific tier?
It really comes down to compounding errors within those autonomous loops we just discussed.
Oh, I see.
If the AI is executing a 50-step financial analysis on its own, and it makes a slight logical error on, say, step 4.
It carries that error forward.
Exactly. It carries that flawed logic into step 5, step 6, and so on. By the time it reaches step 50, the final output is just completely derailed.
Yeah.
Without a human to course correct at step 4, the autonomy actually becomes a liability.
That makes perfect sense.
Yeah.
The longer it runs without supervision on a really hard problem, the higher the chance it just wanders off a cliff.
Right.
And the sources also highlighted broader technical challenges, particularly around data privacy, didn't they?
They did. When you have an AI that is highly efficient at caching data and remembering context across long workflows, there is an inherent risk of data leakage.
Of course.
While xAI quickly resolved early incidents, enterprise users really must understand the mechanics of how their proprietary code or sensitive legal documents are being processed and stored when interacting with these massive models.
Absolutely. Plus, to actually get the AI to perform efficiently, there's a surprisingly steep learning curve.
There really is.
The sources note that to utilize the configurable reasoning, like knowing exactly when to set it to low, medium, or high, it requires advanced prompt engineering. It is not something you just intuitively guess on the fly.
No, not at all. It requires a deep understanding of how the model's architecture actually responds to your instructions.
So what does this all mean? For the listener who is sitting at their desk right now, staring at their screen, trying to figure out how to adopt Grok 4.5 into their workflow today.
Hmm.
How do they navigate these hurdles?
Well, this raises an important question about the human element in this whole new ecosystem.
Yeah.
The consensus from the hard data is that this AI does not replace human ingenuity, it multiplies it. To navigate that 29% pass rate on complex tasks, you simply cannot be a passive consumer of the output.
You can't just hand it the keys and walk away.
Exactly. Users must embrace critical thinking. You have to invest time in understanding the mechanics,
Right.
learning how to guide the AI, how to configure its reasoning settings for the specific task at hand, and most importantly, how to meticulously verify its multi-step work.
So it's a management skill now.
Definitely. The professionals who will truly thrive aren't the ones trying to automate their entire job. They are the ones who learn to manage the AI like a highly capable, incredibly fast, but occasionally flawed team member.
Basically, you treat it like that brilliant but slightly arrogant engineer.
Well,
You trust their math on the simple stuff, but you absolutely double-check the launch coordinates before you press the big red button.
precisely. It is an exoskeleton for your workflow. It is not an autopilot.
Okay, let's bring this all together. What the data shows us is that Grok 4.5 represents a major, undeniable leap in cost-effective, high-tier AI.
Definitely.
xAI has managed to blend this immense 1.5 trillion parameter plumbing system with a slightly sarcastic, highly accessible personality. But the real takeaway for you, the listener, is efficiency.
Yeah, efficiency is the key word here.
It's the ability to execute complex, multi-step workflows at a fraction of the cost and compute power we saw just a few months ago. Elon Musk and xAI always talk about this grand mission to understand the universe, but right now, in July 2026, that mission is taking the very practical form of solving your daily workflow problem.
It really bridges the gap between frontier computer science and the daily grind. But as we wrap up today, I want to leave the listener with a final thought to mull over, returning to the concept we opened the show with.
Oh, right.
We talked about how inexpensive it is now to let Grok 4.5 run these agentic loops in the background.
Right, the $2.49 complex task running autonomously.
Exactly. Well, if agentic workflows become this inexpensive and this capable of running multi-step logic without human babysitting, what happens when two different companies' autonomous Grok agents begin negotiating a legal contract or a financial merger with each other entirely on their own?
Literally the scenario from the start of the show. AI talking directly to AI.
Yes. When the AI is running the show on both sides of the table, making multi-step compromises, redlining clauses, and executing agreements in the background, where exactly does the human accountability lie when that final digital handshake happens?
Wow. That is a wild thought to leave on. We've officially gone from the flashy concept car on the stage to self-driving trucks negotiating the right-of-way on the highway at 70 miles per hour.
We really have.
We are definitely in a new era of the internet. Thank you for joining us on this deep dive. Keep questioning the tools you use, keep verifying the data, and keep exploring this incredible information landscape. We'll catch you on the next one.